Okele dokele. Let's take a look at a good rationalization why the locoder might actually matter. And it might not, but let's see why it might. So what is the point of the whole thing? So autoencoder seems to do a better job, so what's the point? Well, locoder could, in theory, train any architecture. It's not necessarily stuck with the kind of architectures that autoencoders can create. But autoencoders can be stacked and they can be deep too, so there's a little bit of a competition between the two. And then high-level representations can, in fact, be extracted from perhaps autoencoders as well as locoders. Okay, so in next step, basically, is locoder and ImageNet a possibility? So if we have a lot of data, a million images, actually those million images were trained with about 30,000 target objects. So 30,000 target objects needed to be identified in those million images. And the locoder would have a million images and a million targets, so that is about 30 times as many targets. So is that really that different? Not really. But actually, it is different in terms of computation. Locoder can't really use mini-batch or stochastic gradient descent as it is right now. It may be possible to do it that way. But if somebody figures it out. But anyways, so goal would be to get a similar high-level representation to those obtained with the traditional targets. So why is that important? Why does that matter? Well, okay, so we have a lot of unlabeled data in this world. Okay, so now human labor in terms of labeling things is actually the bottleneck. Before, capturing images with quality cameras and storing them and passing them around, that was not so easy. But now we have a lot. The issue is there's a lot of painstaking care that needs to be done in terms of labeling things. So if we could somehow use this immense amount of unlabeled data to create a structure of the network that would be close to what labeled data would mostly create anyways, and then use very few labels to get the final result that we want through the magic of transfer learning. So that would be something special. If we could pull it off, if we could make the locoder do it, but why don't I just do it and then become famous and rich? Well, because locoder, as it is right now, is immensely computationally intensive. So if I make a mistake and bug in my program, it's going to take a lot of money to run the thing again and again and again and again until I get it to work, maybe, and I will never really know if I got it completely done, if I keep encountering suboptimal results. So really the problem is that the mini-batch or stochastic gradient descent in its current iteration just don't really work. And if you can fix that, then locoder could possibly do a good job. The other issue, not stated here, is that locoder, at least from what can be seen in the current results, does not quite capture all the richness of that an autoencoder is capable of capturing. It can detect edges, but for example, when it tries to look at images, it can detect edges, but it doesn't quite do. It has many repetitions in terms of how its nodes, what its nodes represent. So it doesn't really utilize its resources to the maximal extent possible. That's not a good thing. That somehow also needs to be improved. And yeah, so better math to get rid of the issues with speed and with repetitive representations within the network that are happening for some magical reason would both really help a lot so that this can actually be done in a reasonable amount of time. And then there is my sci-fi fantasy, which I have to mention. Actually, LOCOder can check if robot is seeing something that can be identified as a unique experience. So, if the robot is moving about the world and it's recording things and it just takes 10 seconds of every experience that it has and just puts it into a LOCOder, uh, if it can actually identify the experiences that it's currently experiencing fairly easily, then if it can classify it and find it again amongst all of the experiences that it experienced before fairly easily, then perhaps there's not much of anything that's truly being learned, and something like boredom would be getting experienced. And if the experiences are too unpredictable, so then basically, if we again fail to identify it, so this time we're not consistently being right, we're consistently being wrong. So that's also not a good thing. That can get the robot scared that it's in some circumstances that it truly does not feel comfortable in. So that could be something to avoid as well. So somewhere in the middle would be the optimal. So full disclaimer here, I never coded up a reinforcement learning algorithm, and it likely shows in terms of my description of my sci-fi fantasy. So that's it. That's maybe why LOCOder could be developed into something meaningful, uh, but it's up to you to decide, really. So thank you for listening. Bye.